Okay, good morning. Morning. Morning, everyone. It's time to start with our lecture for today. So remember to sign in our attendance sheet. And before we get started, there's a homework posted already. That homework is due on Monday. And basically, it is a homework that is based on the material we cover on Wednesday and part of the material that we're going to cover today. So make sure that you go find the homework. You don't have to submit all the problems. Just there's some of the problems that are marked. Those are the ones that you need to submit. Okay? Make sure that you go download the homework. For those of you who doesn't have the book already, I've posted the problems so you don't need the book to do the homework. But you can use a book as a reference if you want to go over the material and see how the book explains the topics that we're covering in class. The other announcement that I have is I asked you to bring the computers today. We're not going to be using the computers until the end of the lecture, so you can close the laptops. I'll let you know at what time we're going to use them. And let me see what else. So those are the two announcements. So make sure that you do the homework, and also please stop using your laptops until I let you know when we're going to use them. Any questions at this point? Again, the material we cover on Wednesday is very basic. Most of the formulas and the expressions that we discuss in class were already covered, I would say, in other courses. But it's important for you to see how are they related in the context of probability and statistics, and also in the context of engineering. So today we're going to continue on lecture number 2, which is Introduction to Statistics and Data Analysis. But today we're going to focus on the diagrams part. So we're going to learn how to construct some diagrams that will allow you to represent data on a different form, and also will give you an idea of how the structure of the data, so you can make some inference from the data that you have available. So just as a matter of review, we're starting this class on the statistics portion. So we are covering the measures of location and the measures of variability. And I think the last thing we did in class was to cover how to compute the variance. And today we have an extra problem that we're going to discuss, and then we're going to transition into the diagrams. So really quick, the learning objectives, we went through them last time. It's important to remember what we are trying to do in this portion of the lecture. Also remember the difference between populations and samples. Anyone knows what's the difference between a population and a sample? Anyone remember? Yes, sir.
Population being the whole, sample being part of the population.
Correct. So when you look at the population, you're looking at the entire group of units. When you look at the sample, you're taking a portion of those units from the whole group. Very good. So population samples, variables basically provide some characteristics of your unit. And we presented some examples of population objects and variables. And describe again using this pictorial or figure the difference between a population and a sample. Then we talk about descriptive statistics and the importance of them, allow you to summarize and describe some important information or features of the data. And we talk about two methods, the graphical method and the numerical summary. So we already covered this portion. We talk about the mean, the standard deviation, correlation coefficients are going to come later in the class. But we also talk about the mean, and variance. So those specific measurements are part of the numerical summary. Today we're going to focus on the graphical method. So I'm going to show you how to construct a stem and leaf display, a dot plot, and also a histogram. And that's why I asked you to bring your computer. Unfortunately, we don't have computers in this room. So if you don't have a computer, or if you were not able to bring your computer, you can try to group with another person so you can follow what we're going to do in class. So inferential statistics, again, we covered this already, the role of probability, and again, the difference between population and sample. We also talked about sampling procedures and collection of data, and we talked briefly about this. Again, this is something that we're going to go more in depth later in this class. But it's important for you to understand that there's several ways in which you can collect the data from a population. So we talk about random sampling, which is one of the methods that you can use, and also the stratified sampling. Those are two methods from others in which you can basically decide the methodology in which you're going to collect the data from your population. And the last part of the lecture on Wednesday was basically to show you how to compute some measures of location. So we talk about the sample mean and the difference between the population mean and the sample mean. So you remember the population basically takes into account all the units, all the objects, while the sample take into account a group of the population. And you can see the difference in the notation. For the sample mean, you use the little n, and when you compute the population mean, you use the capital N. Also, the population mean is represented with mu, and the sample mean is represented by x bar. We also talk about how to compute the sample median and the difference in terms of when you have a number of objects that is odd and when you have a number of objects that is even. And computed those measures for those two examples. We also talk about the three means and how to compute those. And I believe part of the lab that we had on Wednesday asked you to compute a three mean for the 30%, which is the second problem that we discussed. This one. And finally, measures of variability. So specifically, we focus on the variance and the standard deviation. So again, we talk about the difference between the sample variance and the population variance, and the meaning of this n-1 for the sample variance. We talk about why we need n-1. This is called the degrees of freedom. And the main reason for that is we need to account for this estimator, which is the sample mean. So we are using an estimator to estimate another estimator. So that's why we need to take 1 degree of freedom for computing the sample mean, or the sample variance, I'm sorry. And we discuss this problem. They show you how to compute the sample variance for this group of data, which is on the first column. So you first look at the difference between the sample mean and the observation, and then you look at the square of this difference, and then you look at the sum of this column, which is going to give you this part of the expression, and then you divide by n-1. So today we have another example that is basically same process. I want you to compute for the following measurements the drying time in hours of certain brand of latex paint, and we have 15 observations. That's our sample. and I want you to compute the sample variance. So what will be the first thing that you need to compute in order to get the sample variance? Correct. So you need to get the sample mean, because you know that your sample variance the formula for the sample variance is the following. So again, this is for a sample. So sample variance equals the summation from I equals 1 to n of the differences for each observation squared divided by n minus 1. So the first thing that you need to compute this expression is to compute the sample mean. And the sample mean right, so we need to compute this estimator first. So the estimator x bar is just the average, the sample average, which is the summation of I equals 1 to n of each xi divided by n. So this is equal to 3.4 plus 2.5 plus dot 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 4.8 divided by 15, and that should be equal to 3.79. So now we have this portion, we have this estimator, so we have all the information that we need to compute the sample variance. And again, the more I teach this class, the more I see that students have difficulties computing the sample variance. For some reason, they're not, or based on my experience, there's a lot of trouble trying to understand what this expression means. So once you're able to read what this means, then you know how to proceed. So again, we are looking at the summation of the differences squared. So the easiest way to compute this is just to have a table. You can have xi minus x bar, and xi minus x bar squared. So on the first column, you can list all your observations, so 3.4, 2.5, 4.8, and so on until you get to 4.8. Then for each observation, you have to look at the difference. So you have the sample mean already, so you have to subtract that sample mean to each observation. So in this case, it's 3.4 minus 3.79. So I believe that is negative 0.39. And 2.5 minus 3.79, which is equal to minus 1.29. And so on. So you see what I'm doing, right? Just look at the difference for each observation difference, and now you're going to look at this difference and you're going to square that difference. So this is 0.39 squared, and this one is minus 1.29 squared, and you'll do all the same for all the observations. So for this one, it will be 4.8 minus 3.79. So that is 1.01. and this will be 1.01 schooner. So once you have all the values for this column, the last thing to do, what is it? What do we need to do? We'll add them, and that will be equal to, so the summation will be equal to 13 point. So once you have that portion, then the only thing that you need to do is to look at the number of observations minus 1, which is 15 minus 1, and that is equal to 0.94284 or 0.94. Any questions? So for the purpose of the homework and the exam, you can use 2 decimal digits. So what is part B? How do you compute the standard deviation? The square root of 0.94, correct? So it's just the square root of, so part B equals the square root of the variance, which is the square root of 0.94, which equals 0.97. Any questions? Okay, so that's how you compute the sample variance, how you compute the sample standard deviation. And for now, we're gonna just focus on those measurements: the sample mean, population mean, the frame mean, the median, the variance, and the standard deviation. Can I move to the next slide? Okay. So before we get into the details of how to construct these diagrams, I need you to understand what is the difference between discrete and continuous data. And the data gathered may be either discrete or continuous, depending on the area of application. So discrete data is the data that can only take certain values. For example, the numbers of students in this class. So you cannot have 1.5 students, you can have only integer numbers. 1, 2, 3, 4, 5, and so on. Continuous data, then, is the data that can take any value within the range. So you can have decimal places. For example, people heights could be any value within an integer or within the range of human heights. So you can have values like 6.2, 6.3, and so on. So usually when you're looking at only integer values, you're dealing with discrete data. But when you look at continuous information, such as time, heights, weights, those are classified as continuous, okay, because it can take any values within a range. Okay, so that's, in general, the main difference between discrete and continuous data. So let's get into the diagrams. And we're going to focus on, I believe, are 3 different types of diagrams. So we're going to introduce some simple displays that complement the study of statistical populations. The dot plot, scatter plot, stem and leaf plot, and the histogram. The last one is the one that I'm going to show you how to build the histogram using Excel. And this one is, from all of them, the most important one, the histogram. And you'll see that when we start discussing probability. So dot plot is when the data set is reasonably small and there are relatively few distinct data values. Each observation is represented by a dot above a corresponding location, so you're going to have a line and then you're going to start putting those dots on top of the values. And when a value occurs more than once, then that dot, you're going to put that dot on top of the other one, so you will see them stacked vertically. The dot plot gives you information about the location, the spread, and the string values of your data points. So as an example, here you have measurements of temperatures that were recorded, and I asked you to plot the data using a dot plot. So essentially what you do is you find your minimum and your maximum values, so you can have an idea of the length of your line. Once you have that length, you can divide your line different sizes. In this case, I'm using 10. So each 10 units, I'm having a value. And then you basically go unit by unit and plot the dot into your line. So for instance, for 70, we should have at least 3 values. So if you look here, I believe we have 1, 2, 3, actually we have 4. So we should have another dot on top. But you see the idea. And this basically gives you an idea of what is your mean, for example. So if you look at this data, do you have any idea or a range in which you can say, okay, the mean of this data should be around these points? Any idea? Yes, so it should be around this area right here. And the reason for that is you have a group of data points in this area, but you also have some spread numbers, so you know that these string values are going to push your mean a little bit to your left. Okay? So that's the importance of these data plots. Also, you can see that there's some variability in terms of the observations. So you can go from 30 to 80 something. So you see that there's a large range of observations for this data. Another type of graph is called the scatter plot. And essentially it's the same idea, but in this case you have an extra axis. You're looking also at the values of the y-axis. So a graph on which each pair of observations, x and y, is represented as a point plot in a two-dimensional coordinate system. So in this case, we have an example that shows the percentage of column and also the tensile strength. So when you look at the graph, we have tensile strength in the y-axis, and we have the column percentages in your x-axis. And you can plot the data just as we did for the dot plot. But only in this case, you also have to look for the y-coordinate. So if you were to plot, for example, 15, you have 5 values here. And you see that there were line 7, 7. 7 is here and here, so you put one after the other. And then you have 8, 9, and 10, which are above 7. Pretty easy. Right now, we don't have a way to do these diagrams automatically in Excel, but I'm going to show you how to plot these on a different package. It's called Minitab, and this software is available on the computer labs in the university in this building. but I'm not sure if we have access outside this building. Minitab is very useful software, and you'll find it in some companies, but not all of them. So that's also why I always try to use Excel to show you how to do most of the things in class, because for sure, anywhere you go for work, you're gonna have Excel available. Okay, but I'm also gonna show you how to create these diagrams using Minitab. For the homework, you can use Excel or you can use Minitab. Depends on what you use. So if you want to use either one, it's okay with me. Also, I'm going to post this video in our webpage. So if you have questions about how to use the software, you can refer back to the video. Okay. So the other diagram that we have is stem and leaf displays. So for this one, it's kind of the same idea, but you're going to use the numbers as your ACs. So suppose that we have a numerical data set, x1 to xn, for which each xi consists of at least 2 digits. So you need data observations that consist of at least 2 digits. And you're going to use that information to construct your stem and leaf display. So the idea is the following. You're going to select one or more leading digits for the stem values. Then trailing digits become the leaves. So you're going to list possible stem values in a vertical column. Then you're going to record the leaf for every observations beside the corresponding stem value. And then you're going to indicate the units for stem and leaves someplace in the display. So for example, here we have 5 observations. These are percentages. Let's say these are grades from this class. So we can put these grades into a stem and leaf display. We can use the first digit of these numbers as our stem, and then the second digit as our leaf. So if you look at these numbers, you'll see that the first digit for these two numbers repeated. So you have 3. We have actually 3 numbers that start with 3, and 1 number that starts with 1, and 1 number that starts with 6. So you can use those numbers. You don't need to repeat 3 several times. 1 time is enough, because what you're going to do is you're going to stack the other numbers on the same row. So for example, 33 is represented by 3 and 3, 37 is represented by 3 and 7, and 31 is represented by 3 and 1. So this also gives you an idea how the data is grouped. So you see that most of the observations are grouped within this area. Most of your numbers are close to 30-something, 30 units. Any questions? It's very simple, right? Another example, here we are, instead of using 1 unit as our stem, we are using 2 units. So this means that we have this number, first number represents 6,435, 6,464, 6,433, 6,470. So these are the numbers that are listed here. Okay, because we are using the first 2 units as our stem, and the last 2 units are our leaf. Okay, so this is a decision that you, as a researcher, has to do or has to make. But we can also group this data using a different approach. So instead of using as our stem the thousands and the hundreds, we can only use the 1,000 digits. In that case, the information will be grouped differently. So if you look at these 2 areas or these two rows. If you use only the thousands as your stem, then you'll see only one number in that column and the rest of the units in the second column. And the same way, you can use the first three numbers as your stem, and then the last digit as your leaf. So it's going to depend mostly on the type of observations that you have, and if you can basically see from the data that certain units or the first few units are repeated the most, then you can use them as your stem. I think we have another sample. Okay, so in general, this display conveys information about the following aspect of the data. So identification of typical or representative value, extent of spread about the typical value, the presence of any gaps in the data. So can you, from this figure, maybe this is not the best example, can you identify any gaps in this information? Easily, right? You can see that there's a gap between 1 and 3. So you don't have any 20s in your information. You don't have any 40s or 50s. So this type of display will allow you to see those gaps very easily. Extent of symmetry in the distribution of values and the number and location of peaks. So again, we can see the peaks in this particular example. We can identify 67 as one of the peaks because this is one of the rows that had more units. And the presence of any outlying values. So I don't think we have any outlying values here. But for example, if you were to have something like this, then you can say that since you only have one observation, and this observation is far away from these numbers, then you can say that this observation is an outlier. Okay, because there's a big gap between the last number here and this number. Any questions so far? Okay, so now let's talk about frequency of distributions. So, okay, so far we just computed some information and we're just plotting some data into the paper, but we don't know why are we doing that. We're just basically following instructions. The instructor or the professor wants me to do this. I need to do that for the exam or for the homework if I want to get a good grade. Well, that's part of it, but you also need to start thinking about how are you going to use this information in the future. So the first thing we talk about this class is that we're going to have some data in our job. We're going to be using a lot of data, historical data, and we need to analyze that data if we want to be able to make recommendations, right? We're going to get paid to go there, fix problems. And the only way that you can make recommendations for that problem is if you are able to analyze the information that you have available and you are able to find the best solution for the problem. So usually what you try to do is to get that old chunk of data and you want to use that data to make a prediction. So if I use this data and think the problem, I know what's going on because the data is telling me that that machine is too slow. So I need to do something about that. So maybe one thing to do is to bring a new machine. Okay, but you don't want to know, you want to know what type of machine will be better for the type of process that you have. So sometimes we need to make a prediction. So let's say the machine is too slow, it's creating a bottleneck, I need to produce more units, let me bring the fastest machine that is available. But what will happen if you do that? Then you bring that machine that is very fast, it can create another bottleneck later in the process. So you need to be aware of the type of decisions that you're going to recommend because you don't want to create more problems later on. So that being said, using the same example, what we're trying to do is to get the data. We know the possible recommendation that we need to do, but we want to be able to say, okay, we need to get a faster machine, but not the faster one. We want to get a machine that is this fast. The only way that you can make such type of recommendation is if you can basically forecast what will happen in the future. And that's why probability is very important, because you're going to get this information and you're going to use that information. You're going to put that information, let's say, in one of these histograms. And those histograms, there are some models that are already developed that will create a model that will give you a forecast based on the shape of the data that you have available. You can feed a model, and that model is going to tell you, okay, so based on the data that you have available, this is the probability that this next event can happen. And that's what we're trying to get with this representation of data. We're going to build some histograms. Actually, we need to represent first data with frequency, and we need to find the gaps and so on. But what we're heading to is we're going to get these histograms and we're going to fit models to those charts. And those models are the ones that are going to help us to forecast what's going to happen next. And basically, going ahead here a little bit, but I want you to see what the importance of these data representations. So I'll go over that maybe a little bit later today. So let me just tell you a little bit about frequency distribution. So let's say you have a bunch of information. Sometimes what you need to find out is how often you are within this class limit. So how many observations do you have within this class limit? Let's say you have observations that go from 5 to 30, and you want to split those into beams. So let's say here we have 1, 2, 3, 4, 5, 6, 7 beams. And you want to know how often or how many data points you have in each particular beam. That's what we call a frequency table. So this is something that you can decide, and I'm going to show you a rule of thumb later. The size of the gap or the size of the beam. But once you have the size of the beam and how many beams you want in your data, then you can start counting the number of observations that you have on each particular beam. So the number of observations that belong to each interval is determined based on the interval, and then counting the number of observations that you have within each class beam. Okay? So as you can see here, this table is telling you something. This table is telling you that most of your observations are within this range. Okay? So let's move to the next slide. So this is a little bit more about class limit and width. So the lower class limit is the smallest value that can belong to a given interval. The upper class limits is the largest value that can belong to an interval. And the class width is the difference between the upper class limit and the lower class limit. When designing the intervals, to be using frequency distribution, it is preferable that the class width intervals are the same. So you want to use the same size of intervals for your frequency distribution. There's a variant of this type of representation. Anyone familiar with the term cumulative? What that means, cumulative? Let me go back here, just few slides. So look at this table. Here we have, for the first being, we have 3, second, third, 4, 5, 6, 7. So we have 3, 10, 14, 25, 17, 9, and 2. Okay, so those are the number of units that you have for each interval. Now, when you look at the cumulative frequency distributions, you're going to use those numbers. And say this was greater than 5. I don't remember the other. But the idea is the following. You're going to start counting and you're going to start accumulating based on this class limit. So when you look at less than 5, we know from our table, or our previous table, that there were no units that were less than 5. But less than 10 or 9, we had 3. Now, less than 30, we go here, we have 10 plus the other 3. So we start accumulating these 2 because those 2 means satisfy the constraint. So we have 30. Less than 17, we have 14 plus 10 plus 3, 27. And you repeat the process. Okay, so at the end, you should have the number of units or the total sample as your number of units. And you see how each number is increasing as you go down into your table. Okay, so this is a different representation. And later in this class, we're going to talk about what is a PDF, or a probability density function, and what is a CDF, a cumulative probability distribution. And the idea or difference between these two types of distributions is this. In one, we're going to look at the cumulative value. In the other one, we're going to look only on the units that are within certain limit. Okay, but again, I'm getting ahead. Just look at just understand what is the difference between this term, cumulative. You're going to start adding all the units that satisfy this particular limit, and that includes the beings that are below. For this one, we only count those that satisfy this last limit. Okay, so another variant, we have a measure that is called relative frequency, which is the ratio of the number of observations in the interval to the total number of observations. So here, basically what you do is just look at the percentage. So if you have, for the first being, you have 3 units, and you know that you have 80 observations, this is going to be 3.75%. So if you have 10 units and 80 observations, this is 12.5%, which is this column right here. And that's another type of representation that we can use. So it's basically the same number, but in percentage. The percentage frequency distribution is arrived by multiplying the relative frequency of each interval by 100%. Okay, so the idea behind these frequency distributions is that we want to be able to build this. This is what is called a histogram. And again, this is the basic for a lot of probability models that we're going to discuss in this class. So essentially what we're going to do is we're going to build these histograms, and then based on the shape, let's say this has this shape. Based on the shape of the histogram, we can say, oh, that shape represents this normal distribution, or that shape represents the exponential distribution, or that shape represents the uniform distribution, or the airline distribution, and so on. So that's what we're going to do using these histograms. So the idea is to get those distributions from our data. But before we get to that point, again, histogram is the most common form of graphical representation of a frequency distribution, constructed of adjacent rectangles. The height of the rectangles is the class frequency, and the bases of the rectangles extend between successive class boundaries. So how to construct a histogram from discrete data? Very easy. Again, remember what discrete data is? Anyone? Bonus point for the next exam? What is discrete data? Say that again? Discrete data? It's not? Kinda. What type of value? So discrete data is just integer values. So like 2 units, 3 units, 4 units. You don't have a percentage number, right? So for example, the number of students that we have in class. You cannot have 1.5 students. You can only have 1 or 2. Okay, so that's discrete data. Continuous data is the one that you can have decimal places. Like you can have 6.4, let's say 6.4 or the time, for instance, 1.5 hours, and so on. But discrete data, again, look at the integer number of observations. So if you want to build a histogram based on discrete data, these are the 3 steps. Determine the frequency of each value. So if you have 3, 6, and 7, how often you have those numbers. You are using the dice, you're throwing that dice, how many times you get value of 1, the value of 3, the value of 6. That type of information. Mark possible x values on a horizontal scale, and then draw a rectangle whose heights in the frequency or relative frequency of the value. So, for example, here we have, let's say we're looking at a traffic intersection, and we divide the time in 11 periods. We want to know how often, how many arrivals, or how often you see 0 observations, how often you see only one observation. So let's say you're observing the number of the students that go to Chick-fil-A, and you're looking at the time period from 7 a.m. to 8 a.m. for 11 days. So you want to know from day 1, let's say you have 5 days. You're looking the same time period from, say, 7 to 8 a.m., let's say from Monday to Friday. And on the first day, you observe 3 persons or 3 students. On the second day, you observe 3, but on the third day, you observe 0. On the fourth day, you observe 5, and on Friday, you observe only 1. So how often, or what is the frequency that you observe 3 students? You observe that twice. Okay, so your frequency in this case, let's say arrivals and frequency. So here you're gonna have 0, you're gonna have 1, you're gonna have 3, and you're gonna have 5. So how often do you observe 0? 1. How often do you observe 1? It's 1, right? On Friday, that day you only observe 1. Then how often do you observe 3? 2, right? And how often do you observe 5? Just 1. So that is how, following this example, that is how this table here is created. So that particular example is for a traffic intersection. It's right here. So vehicle arrival example, number of vehicles arriving at the intersection between 7 and 7:05 was monitored for 100 random work days. So for 100 days, you were basically counting the number of cars that crossed that intersection from 7 to 7:05. And you have the number of arrivals that you observed. So you, for those periods, you were able to observe periods in which you have only 0, 1, up to 11. And this is the frequency. So this is basically telling you that you observe 12 times, you observe no cars crossing that street. And 10 times, you only observe 1 car crossing that street. In 19 days, you observe only 2 cars. On 19 days, you observe 2 cars crossing the street, and so on. So using that information, you can create this plot, which is again discrete data. So it will go from 0 to 11, number of arrivals per period, and the frequency is going to be those rectangles that go up to the frequency on the y-axis. So for instance, 0 goes to 12, 1 goes to 11, and so on. And this is also showing you that the mean could be around this area, and the number of times that is repeated the most is 2. So again, this is an example frequency distribution using discrete data. We can do the same thing using continuous data. But in this case, we need to specify the data interval. Because again, we cannot represent continuous data just using integer numbers, because we have decimal places. So in this case, we need to divide the range of data into intervals and label the horizontal axis to conform the selected interval. Then determine the frequency of occurrence within each interval. Label the vertical axis so that the occurrence can be plotted for each interval, and then plot the frequency on the vertical axis. The rule of thumb: for continuous data, you need to know how many intervals you're going to construct. So the rule of thumb is to look at the square root of the number of observations. So if you have 100 observations, how many intervals are you going to use? 10. Correct. Okay. So let me show you typical histogram shapes. So again, once you construct a histogram, you can try to draw a curve based on the histogram. So there will be some shapes that are very common. So for example, this one is symmetric. You can see the curve is the same. If you cut that curve in between, you'll see that they have the same shape on this area. Bimodal, basically when you have two peaks, positively skewed, most of the data is on the left. Negative skewed, most of the data is to your right. And again, this is what we're trying to do. So once we have our histogram, we can draw the shape, and we can establish or define a function for that shape, which is going to be our probability model. So now you can use your laptop. I'm going to show you how to solve these problems. This is for continuous data. As you can see, there's some decimal places in each observation. And we're going to use this example to build a histogram. So the following data are the measures of the diameters of 36 billet heads in 1/100 of an inch. So we have 36 data points. The first thing I want to do is to compute the sample mean and the sample standard deviation. You can do that in Excel very easily. Then we're going to construct the frequency histogram of the data. And the last part is to comment on whether or not there is any clear indication that the sample came from a population that has a bell-shaped distribution or symmetric distribution. So please, if you don't have a computer, try to sit with someone close, has a computer. Don't be afraid. It's a time to meet new people, new students. And again, bad thing about this room is that we don't have a computer for each student. Okay, so let me just compute a couple of things here before we move to the Excel. Okay, so first thing that we need to determine is how many intervals we're going to use. Any ideas? Correct. Anyone else know why 6? Correct. So we're going to look at the square root of the number of observations. So for continuous data, how many intervals? Okay. If you can connect to the internet, you can access the file that I'm going to be using. I already typed that information to that Excel file. If you go to tracks, you'll find an Excel spreadsheet inside the lecture folder. So if you can download that file. So based on this, basically the next thing to do is just to determine the, so we know we're going to use 6 intervals. The only thing that we need to specify is the minimum value and the maximum value. So the minimum in this case is 6.62 and the maximum is 6.82. So the size of the interval is 6.82 minus 6.62 divided by the number of intervals, and that would be 0.20 divided by 6, which is about 0.0333. Sorry, 0.0333. So in this case, we need to round up always. So if we go 0.0333. Again, we are looking at the same size for each interval. So you can go up so we can have enough space to accommodate all the data. If you choose 0.03 and you write the intervals, you will see that you will not be able to cover all the space that you need to accommodate all the information. So we're going to use 0.04 as the size. So that means that we have 6.62, 6.66, 6.7, 6.74, 6.78, 6.82, and 6.86. So these are the means that we're going to use to build our histogram. So the next, if you will do this by hand, the next thing to do is to count how many of those data points are within this interval, how many of those data points are within this interval, and so on. But Excel does that for you, so you don't have to count. Let me show you. Were you able to access this file, all of you? It is inside the lectures, resources lecture in the track side. Okay. So we have the intervals, and this is the information that I just explained, right? These are the intervals, and this is the information. So now I'm going to show you how to count the frequency using Excel. So if you go to this cell here, next to, we can just type this frequency. We can use the equal sign and type frequency. You'll see that formula that shows up. It's called frequency. Then you can open a parenthesis, and you'll see that it requires two things, the data array and the beans array. So the data array is the column which we have all the information. So we're gonna go and select that column. And then put a comma. And now we need to select the beans array. And that will be this column right here. And then we close the parenthesis. So for that first interval, we should have 2 as our frequency. Let me know if you have any problems. Everybody was able to get the 2? Because what we're going to do next is a little more complicated. If you're familiar with Excel, what you will try to do next is to extend that cell, but that will not work. What you need to do with this formula is to select the column and then hit F2. The formula is going to show up. And now you have to hit Control, Shift, and Enter at the same time. So again, you go back here. Everything. Do that one more time. So frequency, open parenthesis, select the data. Comma. Then select the intervals, close the parentheses and hit enter. You will get a 2. Then you need to select the frequency column, hit F2 at the top of your keyboard, F2. That formula will show up. And now you need to hit Control, Shift, and enter at the same time. So now you have the frequency for the data, and we can easily plot this into a histogram. If you go here to the Insert tab, just select a column graph, and that's your histogram. So you see most of the observations are this big. So your mean should be in this area. Any questions? Yes, sir. This part?
Yeah.
Once were you able to get to the number 2 for the first beam?
Yes, I have to.
Okay, so 2, you can hit F. Well, actually, you from 2 to escape. You select the column, right? F2.
It's not working.
It's not working for you?
So what's the shortcut doing? What's the F2 shortcut for?
Oh, the F2 is just showing the formula. So if you're not seeing the formula, then it will not work. So you select shows, F2 shows the formula, and then Control, Shift, and Enter at the same time. If it's not working, I can show you after the class. But once you get the frequency, you can plot the graph. Easy. Now let me show you. Any questions? Okay, let me show you how to do this in Minitab. So if you go to the lab, you can find Minitab. I think the version that we have is Minitab 16. And Minitab is a software package that is this software is built to do statistics. So you'll see this in other courses for industrial engineering. You'll keep using this software. So what you do here is very easy. If you have the data already in Excel, you just copy that information from Excel. And then you go here and put that information in your first column. Just paste that. And then you can go here to Graph and tell Minitab to do a histogram. Simple histogram. Okay. This is I think the most difficult step is just to remember to select the column in which the data is. So if you select that column and then hit select, that column name will go here into graph variables, and then hit OK. There's your histogram. Just a little bit different because it is using a different number of intervals, but you can edit that here. Edit bars, custom. You can tell them just use 7 and the shape will change. Actually, we're using 6. So you can basically accommodate the graph in such a way that it will look the same. But that's another option that you have. Again, for the homework, you're asked to do several things. If you can use Minitab, it will take you very, like you can do this very easy. You can do the dot plot. Again, select the column with the data. And you have your dot plot right there. The scatter plot is just the same thing. Just go graph, select the scatter plot, and it will plot everything for you. So this is another option that you can use for your homework. Again, since you don't have access to the computer here, I'm going to post the video so you can follow the steps if you want to use this software for your homework. The homework is due on Monday. I'll be available the rest of the week if you have questions. And you can also send me emails with your questions. Okay? Any doubts at this point? Yes, sir. Okay, I can check with you. Any questions? Okay, so I'll see you Monday.